One interesting application of the derivative is in economics when we're talking about supply and demand. So suppose you are manufacturing paper clips and the machine you used costs $50, but the cost to produce an individual paperclip using that machine is just 5 cents per paperclip. You estimate you can sell X paperclips at a price of 5,000 minus X over 10,000 dollars per paperclip. And we're wondering how many paperclips should you produce to maximize profit, and what is that profit? So we're going to have two main functions that will tell us the rest of our story. We have a cost function, which is how much it costs to produce X paperclips, and a demand function, which basically tells us what price should I charge if I want to sell X paperclips. So my cost function here is going to be the initial investment I made, which is $50, plus 5 cents per paperclip, which gives me 50 plus 0.05x. My demand might be determined by market research, and what this is basically saying is, say for instance, I wanted to sell 4,000 paperclips. Well, then I would need to price them at 5,000 minus 4,000 over 10,000, or essentially 10 cents per paperclip, in order to be able to sell all of those. If instead I only wanted to sell maybe 1,000 paperclips, I could get away with just pricing them at 40 cents a paperclip instead. So there we have that. And I've gone ahead and rewritten that using decimals because that'll make our life a little easier. We also have a revenue function which tells us how much money we're actually making. And that's going to be given by the price per paperclip times the amount of paperclips sold. That's going to be 0.5x minus 0.0001x squared. So we just multiplied p of x times x. And the profit, what we want to maximize, is given by the revenue minus the cost. That's going to be 0.5x minus 0.0001x squared minus the cost, which is 50 plus 0.05x. We can go ahead and simplify slightly to make that, that's going to be equal to 0.45x minus 0.0001x squared minus 50. We want to maximize that. Now we're going to talk about how to maximize functions in this class very soon. But there is maybe an intuitive way we could think about this. We're going to think about the marginal cost and the marginal benefit, or sorry, the marginal revenue. The marginal cost says how much does it cost to produce one more paperclip. Whereas marginal revenue says how much more do I earn by selling one more paperclip. So we can kind of get an idea for what these will be just from context. So we know actually that the marginal cost is just going to be 5 cents because it always costs 5 cents to produce a paperclip. But the marginal revenue is a little bit more interesting because, well, as we produce more and more paperclips, we have to start selling them for cheaper and cheaper. So the marginal revenue is actually going to be going down over time because as we produce more paperclips, or as we hope to sell more paperclips, we're going to have to reduce the price to do so. So what we might ask is, when is the marginal cost less than the marginal revenue? Because as long as the marginal cost is less than, or maybe even equal to, the marginal revenue, we're still making money because it's costing us less to produce the paperclip than we're making by selling it. So I want to sell whenever the marginal cost is less than the marginal revenue. At some point, those things will be equal, and then past that point, then it's going to flip around, where the marginal revenue will now be more than the marginal, or will be less than the marginal cost, meaning that I will be making less money than it cost me to produce the paperclip. So we want to find where the marginal revenue equals the marginal cost. Because as long as we're producing up to that number, then marginal revenue is greater than marginal cost. But as soon as we start selling more than that, then marginal revenue is less than marginal cost. So that's great, but what is the marginal cost and what is the marginal revenue? Well, what will be the units on these things? We're talking about the cost per paperclip, and we're talking about the earnings per paperclip. These things are actually going to be the derivatives of the cost and the revenue functions. So the marginal cost is just going to be the derivative of the cost function, which is 0.05. We actually knew that already from the context. The marginal revenue is going to be the derivative of our revenue function, which is going to be 0.5 minus 0.0002x. So, and that kind of matches what we saw earlier. The marginal revenue is going down because the more we sell, or the more we try to sell, the lower we have to price them. So, when does the marginal revenue dip below the marginal cost? So we're going to go ahead and find out where that is. So we're going to go ahead and solve this equation. It's a nice linear equation. We'll maybe start by subtracting 0.5 from both sides. We'll get negative 0.45 equals negative 0.0002x. I'm going to go ahead and multiply each side by negative 10,000 just to clear the decimals out. And also to get rid of that negative sign, we'll get 4,500 equals 2x. Divide by 2. And we finally get an answer of x equals 2,250 paperclips. So this is where, as we've been saying, that's where the marginal cost, or where the marginal revenue is going to cross over the marginal cost. It's where the marginal revenue is, it's where they're equal, which means that past this point, it's going to cost more to produce a paperclip than we're going to make by selling it. So this is the number of paperclips that we want to produce if we want to maximize our profit. So we've answered the first part. We set the marginal cost equal to the marginal revenue, and that gave us our answer. But how much are we actually making? If we go ahead and plug in 2,250 to the margin, or to the profit function, what you'll find is we will get an answer of roughly $456.25. So, and that's just plugging it in for X for what we got up there. So that would be the profit that we make at that point. So just to conclude, if we want to find, if we have a cost function and a demand function, first of all, we find that demand function to get our revenue function, and then we want to find where does the marginal cost equal the marginal revenue. That point is going to be basically the amount that we want to produce in order to maximize profit. So there's a little bit of where derivatives come in handy when we're doing some economics.